line. What may not happen is that the operating system closes that port. Next time you send a message, it picks another port, opens it, and sends. After about an hour or two, you can have 20 ports open that you don't use anymore. However, the operating system starts slowing down because it has to handle 20 ports, then 30, then 40. And now your messages don't seem to get through properly. There's a long delay, they may not get there. And when you're doing testing, this may confuse you because you think you've written a nice little program and suddenly it's not doing so well anymore. Where is the problem? So in this one, Alex Tweedley has put in a small loop, and what I'll do is magnify the loop just so you can get the idea of why we do sockets and maintain them. Here we are looking at this information, and I will magnify it. What we're looking at here, and I will do it this way. I will put a blue item here. If the open sockets is not empty, that means we have at least one socket open. We're going to repeat for each line in the open sockets. We're going to analyze this line, and if it doesn't fit our particular rule, which in this case, if it doesn't contain a semicolon, then close the socket. It means it's one of these that's just been opened by the operating system and we don't care. So we go through however many there are and just keep closing anything that doesn't have a semicolon. And in this case, that would mean all the extra stuff that's overhead. And that keeps it clean and lean so you do get your good communication channel. In another little moment here, we'll start seeing, well, probably won't start seeing for this demo. Wait for 200 milliseconds. This particular handler is a startup handler. You'll use it once and then you won't have to worry about it again. So the wait for 200 milliseconds doesn't cost you anything here. This is a one-time event or one every hour or something like that. So you don't care, but waiting 200 milliseconds is important because I will show you that what we're doing is we're putting something into a field, and after this maintenance, we're waiting for 200 milliseconds to let the operating system finish its little maintenance that we've just told it to do before going on. If we don't do that, we might sort of overrun the ability for the operating system to maintain and keep itself all cleaned out. Now, these may sound like complicated concepts, but when you start with a nicely written stack like Alex Tweedley has done, he's put these in here and you can just simply use them as they are because they work. And later on you can figure out if you have to refine them. Now in my case, I had to refine them because we were trying to extract a higher performance and some data integrity. So I had to build in some loops that said the message got there, thank you, or it didn't get here, and therefore the timing said resend it. So I had to build those little things in, but the idea was that most all the time everything worked smoothly as long as I did the right maintenance. So in testing, these two stacks will open up and run on your computer in a single development environment, and you can go back to version 2.7.2 of Revolution if you want, because all of these reserved words, functions, and features were in Revolution 2.7.2. I don't believe they've changed since then because they've just always worked. I'm going to look a little further into the script now because